So Pythagoras was a guy, and he discovered this theorem. Over 2,000 years ago, he discovered that when a triangle has a right angle in it, a 90-degree angle, and squares are made on each of the three sides. Notice this square is bigger than that one, and this is the smallest of all over here. Found out that taking those squares, that the area of that and the area of that fit inside and was exactly the same size as the area of that biggest one. So what he found out, and he discovered that that's true for all triangles with a right angle, that the leg squared plus the leg squared equals the hypotenuse squared. And we've already done the Pythagorean theorem several times this year, actually multiple times. Well, now we're going to be taking it a little bit further. So the biggest square has the exact same area as the other two squares put together. So that's where this came from. A squared plus b squared equals c squared. You got to know that a and b make the right angle, or that the right angle is between the legs. So think about this. A square with a side of a and a times a would be its area. You do length times width when you do area, so a times a is where the a squared comes from. Show you another picture to illustrate that. B times b, b squared, c times c, c squared. That's the area of those squares. There's a special set of triangles called the 3, 4, 5 triangle. That is called the Pythagorean triple because these are all integers. Now you can see it visually how many squares there are here. There's 9 of them in that box. That's where 3 times 3 gives you 9. 4 times 4 is 16. 5 times 5 is 25. That's where these numbers came from. And this plus this, 9 plus 16 is 25. And it always works. If you look in your ISN now, we're going to talk about the Pythagorean theorem and its converse. This is the first thing we'll do, and then we'll do the examples in your packet. The Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared, or you've seen it just now, a squared plus b squared equals c squared. If three whole numbers, a, b, and c, satisfy the equation, a squared plus b squared equals c squared, and they're whole numbers, what does that mean? Whole numbers are numbers like, my pen is stuck, so just a sec, I'm trying to get this to cooperate with me. It's just doing weird. Okay. Why is this sticking? Do you know what a whole number is? Like 1, 2, 3, 4, 5, 6, on and on and on and on. Okay, they're not decimals. That's Pythagorean triple example. 3, 4, 5 is a Pythagorean triple. And we're going to discover another one right now doing number 1. The legs here are a and the 12. So a squared plus 12 squared would equal. The hypotenuse, guys, is always across from the right angle. That's your hypotenuse. So I'm going to go ahead and label those. This was a leg. This is a leg. If that helps you, then label them. This is your hypotenuse. So a squared plus 12 squared equals 13 squared. 12 squared is 144. 13 squared is 169. Next, to solve for a squared, you're going to subtract 144. You get a squared is 25. Next, we take the square root of both sides, and the square root of a squared equals the square root of 25. The square root of a squared is a, and the square root of 25 is 5. So we just found out that 5, 12, and 13 are a Pythagorean triple. Okay, let's check out what happens on number 2. On number 2, 20 is a leg, 30 is a leg, and the side across from the right angle C is your hypotenuse. So we do 20, I'm going to write that up a little bit higher. So we got 20 squared plus 30 squared equals c squared for this problem. 20 squared is 400, 30 squared is 900. When I add 400 and 900, I get 1300 equals c squared. Now I take the square root of 1300, and I'm going to show you something besides writing it as a decimal. I have some students who are both enrolled in Algebra 2 and in Geometry. You probably already know what I'm going to be talking about simplifying the radical. If you are not, that doesn't matter. You've simplified radicals back in Algebra 1, but you might not have understood it real well back then, and hopefully you will this year, and you will need to next year. But this year, we are gonna do some simplifying of radicals. So what I'm going to say to you is, do you know the perfect square numbers? And we're going to talk about simplifying radicals more in the next couple of days. Perfect squares are numbers like 2 times 2, which is 4. 3 times 3, which is 9. 4 times 4, 16. You're supposed to know these, your times tables. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, etc. 81, 100, 121. Okay, and I'm going to give you, you're going to have a chart in your ISN that has the perfect squares on it, amongst other things. Any of those, by the way, that divides into 1300. 1300 is pretty big. So I know 25 would go into it because it ends in zeros. But how about something bigger? 13, I said Evan? 36? I don't think 36 does. Price? 100. 1300. Heard me say it like that? We can break 1300 apart into 100 times 13. Okay. When you do radicals, if you have a product, you can undo them and multiply these and say square root of 100 times the square root of 13. The square root of 100 we should know, because 10 times 10 is 100. The square root of 100 is 10. So that's 10 times the square root of 13. If you were doing, a standardized test, it would probably have radical form for the answers. Now, I'm going to take a lot of these with decimals, unless they're easy to do, like this one was kind of easy to do, simplifying. I'm not going to make you simplify radically really big numbers, but we are going to practice it. So what is the decimal form? And I'll show you how that these are equivalent. So if you type second and then x squared, square root of 1300, on this particular problem, I probably would have just taken the answer. 36.1 would be to the nearest 10th. But look, 10 times the square root of 13, you can find out that that is exactly the same thing. Okay, so there is a way for you to do it. If it's multiple choice, you can check your answers in the calculator. All right, so we got 36.1 or 10 root 13. Okay, the next one on your paper is taking a rectangle and drawing in the diagonal, which would be the hypotenuse. Then 16 is a leg and 33 is a leg. So we would do 16 squared plus 33 squared equals x squared. And you could start with x squared. It wouldn't matter which side it was on. I'm just going to type that on my calculator. 16 squared plus 33 squared. And then that is 1,345. I am not going to have you try to figure out if that is simplifiable in radical form. Just take the square root of it and we'll write the decimal. So second, x squared 1345 is 36.7 to the nearest 10th. Okay. Now we're going to look at the converse of the Pythagorean theorem. I had taught you earlier this year that in order to make a triangle, the smaller two sides had to add up to something bigger than the third number, okay? So you have to be able to determine whether you've got a triangle in the first place or not. But the converse of the Pythagorean theorem can tell us whether the triangle is a right triangle, an acute triangle, or an obtuse triangle. And quite frankly, I'd like to take this one and reverse it. So if c squared equals a squared plus b squared, then it's a right triangle. That's the same as what this says. If c squared is less than a squared plus b squared, it's acute. If c squared is bigger than a squared plus b squared, then the triangle is an obtuse triangle. You must put in c first. Do c squared first. Okay, so we're going to determine whether PQR is an acute, right, or obtuse triangle. The first step is actually to determine if these numbers are the possible sides of a triangle. So what you would do is say 3 plus 5 is bigger than 6, and that is true. So yes, you can have a triangle. All right, now granted, they drew one, but I'm going to show you what I'm talking about more on the next question. So we know it's possible to have a triangle with these lengths of sides. Now we're going to determine whether it's acute, right, or obtuse. Now we're going to take c squared, which would be the longest side. So we're going to call that one c, and this one a and b. Okay, so we're going to start with that, 6. And we want to compare 6 squared to 3 squared plus 5 squared. 6 squared is 36. Type on your calculator 3 squared plus 5 squared, or do 9 plus 25 in your head. That's 34. How does 36 compare to 34? Is it greater than, less than, or equal to? That's what you got to think. 36 is greater than 34. Since c squared is greater than a squared plus b squared, the triangle is an obtuse, excuse me. I wrote an A. I was going to write N. Is an obtuse triangle. If I could spell today. That's how this works. We're going to do some more examples now. It says determine whether each set of measures can be the measures of the sides of a triangle. Remember that the sum of any two sides must be bigger than the third. So first, I'm going to have step 1. I need to find out if it's a triangle or not. So I take the smaller two numbers, 3 plus 5, and I say, is that bigger, greater than 7? That's the question you're asking yourself. The answer to that is yes, 8 is bigger than 7. So that means you continue on because you do have a triangle possible with those numbers. The second step is to classify. And the way you classify it is you take the largest side, 7, and square it, and you compare that to 3 squared plus 5 squared, the smaller two sides, squared and added. 7 squared is 49. 3 squared plus 5 squared is 9 plus 25, which is 34. 49 is bigger, greater than 34, so the triangle is obtuse. Okay? All right. Try another one, B. First, determine whether you got a triangle or not. Take the smaller two numbers. Okay, 20 plus 35. Is that greater than 40? And the answer would be, of course, yes, 55 is greater than 40. So that means we have a triangle. Next, step 2. We're going to classify it as obtuse, acute, or right. To classify it, you start with the biggest number, 40 squared. Now you're going to square them. Up here, you're just adding lengths, okay? to tell, so don't confuse this step with this step. 40 squared, how does it compare to 20 squared plus 35 squared? Well, 40 squared is 1600. 20 squared plus 35 squared, I wish someone would type that please on their calculator for me and tell me what you're getting. Okay, so 20 squared plus 35 squared, I was just clearing up that I wrote that messy. You said 1625? Okay, so 1600 is less than 1625, which means c squared is less than a squared plus b squared. Over here it was c squared was greater than a squared plus b squared. That's how come it's obtuse. This one would be, it's an acute. Okay, acute triangle. I hope you're writing good notes. Tend to forget what we're supposed to do on these. All right, so for next one, the first step, check if you have a triangle by doing 11 plus 17. Is it greater than 30? 11 and 17 add up to 28. 28 is not greater than 30, so no triangle, and you're done. That's it. There's no possible triangle anyway. You can't make one. So you don't have a step 2. All right, so let's do the last one. Take the smaller two sides. 18 plus 24. Is that going to be bigger than 30? Well, pretty obviously, yes, right? Okay, so then you do step 2. That was step 1. Step 2. Now you take the biggest number, which is going to be like your C value, and you take 30 squared. And then you check how 18 squared plus 24 squared. You type on your calculator 30 squared. If you don't know, that's 900. You type on your calculator 18 squared plus 24 squared, and you find out you get 900. If you get they are equal, then triangle is a right triangle. All right, so you've got all the 4 different things that can happen. You get a triangle and it's classified out to be obtuse. You get a triangle and it classifies out to be acute. You get no triangle, and then the other one choice is it classifies as a right triangle. Okay, I think that's all for the ISN today, right? Okay, so to the packet that you grabbed, I already looked at the link. I'm going to move on and just start with the warm-up, please. Radicals again. I need you to know the square root of x plus the square root of x. Not right now. That was not the appropriate time for that. Oh, stuck. Okay. Square root of x times square root of x. It's like these guys. We're going to call this radical thing jail. Okay, I'm going to say that these guys are in jail. If you're in jail, you can hang out together. And I know this sounds weird, but it helps you remember things about radicals. So if you're in radical jail, you can hang out, which means you can multiply. So you can multiply these numbers underneath if they're both underneath the radical. So radical times radical, go ahead and multiply what's under there. So this would be the square root of 3 times 3. Just like here, this would be the square root of, what's x times x? X squared. Okay. And guess what the answer to that is? What have we been doing every time when we unsquare? We get x. We just were doing that on the last problems with the Pythagorean theorem. We took the square root of something squared, of c squared, we got c. Okay? So here, this is the same as, and I'm not going to write this every time, but this time I'm trying to explain why what square rooting is. 3 times 3 is 3 to the second, agreed? Okay? And the answer to that is 3. Now, you might be saying, well, wait a minute, 3 times 3 is 9, Ms. Heimer. Yeah, I know. So what's the square root of 9? 3. That is why the square root of 9 is 3, because it's 3 squared. Okay, so I'm going backwards. I'm trying to teach you that 9 is a 3 times 3. When you're a twin, you're a double, you get to come out of jail. Okay, so he's not in jail anymore. He's outside. This guy, this will be the square root of, I know what you're going to do. You're going to do 2 times 2 and get 4. And what is the square root of 4? 2. Okay, that's the answer. It also goes hand in hand with the square root of 2 squared, okay, which is 2. All right, so I'm trying to get you to think about pairs of things so you can simplify radicals. Now, down here on number 3, is 5 in jail? No, it's outside. So if he's outside of the jail, he can hang out with these guys inside. Okay, so we've got to leave him out there. And these guys can hang out because they're in jail. So that's going to be the square root of 2 times 2. And that's the same as 2 squared, or the 5 times the square root of 4. But we already know the square root of 4 is 2. Now, why did he get to come out of jail? Because he got to be a twin. And once something's a twin, one of them can come out of jail and start their new life as the number 2. So this is 5 times 2. Okay, and the answer now is, now they're outside of jail so they can hang out, so you can multiply them. 5 times 2 is 10. So the answer to that is 10. Okay, let's try one more. We got a twin once we multiply. So we got 8 times the square root of 3 times 3 is 9. 9 is a twin. Bring him out. He starts his new life when he comes out as the number 3. So we've got 8 times 3. They can hang out now. We can multiply them. 8 times 3 is 24. All right, we will practice more with radicals going forward. So today, though, let's now hit back to the Pythagorean theorem. I already mentioned this in your ISN, but you have blanks to fill in on your worksheet. If 3 whole numbers, A, B, and C, satisfy the equation a squared plus b squared equals c squared, then the numbers a, b, and c form a Pythagorean triple. For example, 3, 4, and 5 is a Pythagorean triple, and that's because 3 squared plus 4 squared does equal 5 squared, because this is 25, and so is that. 25 equals 25. All right, so we got our Pythagorean theorem jotted down there. Let's move on from that. You have a couple of problems before this, right? They were right from the ISN. All right, so I can go back for a moment, and I will go through those very quickly because we already did them in the ISN, and I don't want to spend a lot of time on it. What is it? Oh, look. I should have one here with me. I do. Okay, so you've got A, 12, and 13. Okay, you have an A here, a 12 there, and a 13 here. So we're going to do A squared plus 12 squared equals 13 squared. That's A squared plus 144 equals 169. Subtract 144 from both sides. A squared is 25, and then we took the square root and got A is 5. The second one that you have there, and so my numbers are going to be wrong, so I'll fix them as I go here. We've got 20, 30, and C, and this is the other one we did in our ISN, so I probably should have just taken it out of here. 20 squared plus 30 squared equals C squared. We got 400 plus 900, which was 1300. We took the square root of 1300. And radical, maybe this will help too about simplifying radicals after me talking about how you multiply them. The square root of 100 times 13 we discussed could be a way to write this. Oh, I shouldn't have the squared anymore on that, excuse me. That'd be 10 times the square root of 13. Or we did the decimal and got, was it 36.1? Someone squared it. Okay. All right, we already went over those, so let's move on to number 3 and 4. On your paper, this says number 3, and this one is number 4. And I don't know what's wrong with my 3. Okay, so the 3's are legs. That's a leg. And the X is the hypotenuse, because it's across from the right angle. If you like to use highlighters, you might want to just highlight the sides that make the right angle, because those are your legs, and then your longest side is opposite the right angle. That's always the hypotenuse. So I'll just quick highlight these. These would be your legs in pink. Okay, so we've got a leg and a hypotenuse. And if it helps you just to label with the words, do it. Well, I'm going to start with X, because I think we need to get used to starting with the biggest side so we do that Converse problem right. So let's just go X squared equals 3 squared plus 3 squared. Okay, so we're going to simplify this because I got 9 plus 9. So how many 9s is that? That's 2 9s. So if I added them, I get 18, and then I take the square root of 18. I want to simplify this using radicals. Okay, what can you break 18 down into? Well, where'd it come from? 2 9s, right? So isn't this equal to the square root of 9 times 2? 9 times 2 is 18, agreed? And 9 is a perfect square. So let's do take the square root of the 9. He's a twin. He gets to come out, and he's no longer in jail now with the 2. So this would be 3 times the square root of 2. If you did this on the calculator, the decimal answer would be 4.2, I believe. Okay, size-wise, that means more to you than a radical. Simplified. I like to put that word in quotation marks, simplified. Because some kids say, well, how's that simpler than just pushing in the calculator? It's really not. Okay, number 4, I've got the hypotenuse. I'm going to start with 15 squared equals legs X squared plus 9 squared. And I don't care if you write this backwards from me. That doesn't matter to me at all. That would be 225 equals X squared plus 81. We're going to subtract 81. What's 225 minus 81? Yep, 144. So, this is a nice one. The square root of 144 is X, so that's 12. Okay, this is number 5 on your paper. Sorry I need to change this. Okay. I have the hypotenuse, again, is across from the right angle. And really, if you just want to start with the legs, that's completely fine. I'm going to go ahead and do that now. I'll just go with leg squared plus leg squared, because you guys like to start with your X. So X squared plus 25 squared equals 65 squared. Well, 25 squared is 625, and I really don't know what 65 squared is, but I know it's over 3,000, I think. What is it, 4,000? Thank you. Okay, perfect. Glad you did that for me. So I didn't even have to get my calculator out. Okay, so I subtract 625 from both sides, and that's going to give me 3,600, I can tell. And then we're going to take the square root of 3,600. You want to check if that's a perfect square. Yep, there is. It's 60. Okay. We are going to do fractions on the next one, so please do not try to do something else. These are my legs. They make the right angle. Across from the right angle is my hypotenuse. Okay, so leg squared plus leg squared. X squared plus 4/9 squared equals the hypotenuse 5/9 squared. How do you square 4/9? Does anybody know? Want to tell me? Because I'm sort of sick of hearing myself. I'll have to repeat what you say, though. Anybody know what to do? I mean, just do it without a calculator, please. All you do is square the top and the bottom separately. So what's 4 times 4? All right, that's the top. What's 9 times 9? 81. Okay, square 5/9. 5 times 5, 25. 9 times 9, 81. These have a common denominator. We can just subtract 16 over 81 from both sides. Now, when you subtract fractions or add fractions, what do you actually work with? You check to see if the denominators match, and if they do, what do you do? How do you subtract 25 81st minus 16 81st? You guys should know this. This is back to elementary school. If the denominators match, you just do what? Subtract the tops, okay, which are called the numerators, all right? All right, let's do 25 minus 16. And I heard some of you, I think you were thinking correctly. 25 minus 16 is 9, right? So we got 9 over 81. All right, well, we can take the square root now. Square root of 9 over 81. What's the square root of 9? 3. What's the square root of 81? 9. What's 3 over 9 reduced to? 1 over 3. Divide by 3, top and bottom. 1/3 is the answer. 1/3. That was very doable without using a calculator. Now, can you use a calculator? Yes, and I'll explain how. Okay, if you're going to type 4 divided by 9, wasn't that it, right, the first one? And then, you can't do it like this, because if you hit squared, it will give you a completely wrong answer, okay? All wrong. Here's why. 4 divided by 9, if you put in parentheses and square it, then you can get the right answer by hitting your math, enter button. It will give you back that fraction 16 over 81, just like I told you it was. Okay? So what did you need to do? You had on the right side, I forgot. What was the right side? So I can show you how to type it on the calculator. It was 5/9. Okay, so if you needed to do the 5 divided by 9, close, square it, you needed, oopsie, I put the wrong thing in. So I need to square that. Oh, sugar. Oh my gosh. Okay, finally. And I needed to subtract, oh, it's still in the exponent. Oh my God. All right, I'm having calculator issues. I had to get out of that exponent, and if I were to subtract from that the 4 divided by 9, quantity squared, and then if you hit your math, enter, but I wanted you to see how to do it by hand. It gets you all the way to, it gives you 1/9, but then we had to take the square root, which was 1/3. Okay, we still would get the same answer, but you would now have to take the square root of 1/9. All right, moving on. I did it without the calculator. This thing has a right triangle in it, and this must have been a rhombus because it has perpendicular diagonals. Okay, so your hypotenuse is the long number, long side. This is going to be a leg, and the hypotenuse. So that's x squared plus 11 squared equals 28 squared. How many of you are typing 28 squared minus 11 squared? Is anybody doing that? You just do that right away? You can, okay? Because you're going to have to subtract. Okay, but you can find out, what's 28 times 28, please? Or 28 squared? How much? 784? Okay, and then we're going to subtract 121. If you have directed studies, you might have been told just to do 28 squared minus 11 squared, and that's perfectly fine. It gets you the same answer. So that's 663. Okay, and then we take the square root of 663, and that's about, I don't know, second x squared 663. Okay, that's square root 25.7. We'll go to the nearest tenth. Okay. Number 6, use Pythagorean triples. You guys don't know these by heart, Pythagorean triples. We're just going to use our leg squared plus leg squared equals hypotenuse squared. So x squared plus 8 squared equals 17 squared. Sorry, I wrote that goofy. X squared plus 64 equals 289. Subtract 64. X squared is 225. And then take the square root of 225, and you should be getting 15. All right, and this one, you can start with the hypotenuse if you like, but x squared equals 45 squared plus 24 squared. That is large. Okay. Like leg, hypotenuse. And then you know what to do. Square root of what that is. You guys find that one, please, so I can keep going. This one, again, x squared equals 28 squared plus 96 squared. 28 squared plus 96 squared. I don't know why I'm doing this one. I didn't finish the last one, but that's all right. Oh, wow, we got 10,000. What's going to happen when you take the square root of that? Yeah, the square root of that is 100. Now I want to do a few examples with the converse. If the leg squared plus a leg squared equals the hypotenuse squared, you can write a squared plus b squared equals c squared if you want. Then the triangle is a right triangle. If the two sides of the equation are not equal, then the triangle is not a right triangle. Okay, so did I go too fast? Okay. All right, now let's see how we apply that. Remember that this box, I like how it's written. Oh, because it's got, just trying to get a pen, Heimer. This is c squared, and c is the, start with c. And c is the largest side. All right, largest side. All right, if a squared plus c squared equals a squared plus b squared, you got a right triangle. If c squared is less than a squared plus b squared, you got an acute. And if it's bigger, then you have an obtuse. Very important that you start. But we first want to justify whether we have a triangle or not. 30 plus 40, is that bigger than 50? The answer is yes. So you continue on. Step 2, classify it. Take 50 squared first. And then look at 30 squared plus 40 squared. You should get 25,000 on both sides. Got it? Not 25,000, 2,500. These are equal, therefore this triangle is a right triangle. I need to get through at least one more, so you can do your homework then. Now this one, start First, decide, is it a triangle? 30 plus 40 is greater than 40 is a yes. Then you classify it for step 2. You start with the 40 squared, and you compare it to 20 squared plus 30 squared. 40 squared is 1600. 20 squared plus 30 squared would be 400 plus 900, which is 1300. So 1600 is greater than 1300, so this triangle is an obtuse triangle. Okay, I have time to do one more. This one, 18 plus 24, you stay where you are, please, is greater than 30 is a yes. 30 squared compared to 18 squared plus 24 squared. 18 squared plus 24 squared, is that 900? Somebody check for me. It is 900. Oh, this is another right triangle. Okay, we are going to continue on to something else tomorrow. Stay where you are. You do not have to sign up at the door. Sorry, guys. Hold off. I will take questions on this. Make sure you do some practice. Okay, first we're going to determine whether it's a triangle or not. 6 plus 8 must be greater than 9. It is, so yes, we have a triangle. And now the second step is to classify it. So if we want to classify, you need to compare the largest side squared to the sum of the smaller two sides squared and added. 9 squared is 81. 6 squared 36 plus 64 would be 100. 81 is less than 100. Therefore, this would be an acute triangle. Number 14, first say 6 plus 12, is that greater than 18? And the answer is no, because 6 plus 12 is 18. 18 is not greater than 18, so we have no triangle. You don't continue on at all. Number 14, add 10 plus 15, it must be greater than 20, and that's a yes. So classify it. Start with the largest side, 20. 20 squared, compare that to 10 squared plus 15 squared. 20 squared is 400. On the right side, you could type in your calculator, you get 100 plus 225, which would be 325. 400 is greater than 325, so we've got an obtuse triangle. Tethers to support a flagpole. A 50-foot long tether is tied to a pole at a point 40 feet above the ground. The tether is pulled out, taut, and tied to an anchor in the ground. How far away from the base of the pole is the anchor? All right, first of all, let's get a flagpole. Okay, we've got a 50-foot long tether. Tethers go from a point on something and then are anchored to the ground. It's like they're supporting it. And this is 50 feet long. It's tied to the pole at a point 40 feet above the ground. So that would be here. And then your flagpole should be perpendicular to the ground. So there should be a right triangle here. Tether's pulled taut to an anchor. This is where the anchor would be. And how far away from the base of the pole is the anchor? So we put an X down here on the ground. 40 is a leg, X is a leg, and the 50 is the hypotenuse. So x squared plus 40 squared equals 50 squared. 40 squared is 1600. 50 squared is 2500. Subtracting 1600 from both sides gives us 900. And then take the square root and we get 30. So it's going to be 30 feet from the anchor to the base of the flagpole. An airplane lands in an airport 60 miles east and 25 miles north, as in the diagram. Of course, this is north, and this would be to the east. Not that that matters. So, nope, not even worrying about labeling that. Let's just say we've got the Pythagorean theorem. We're going to be finding the hypotenuse. This is how far apart are the two airports. So, x squared equals 60 squared plus 25 squared. 60 squared is 3600. 25 squared is 600 And when we add those, we get 4,225. We need to take the square root. I'll double check that on my calc. 60 squared plus 25 squared. And then take the square root. Square root of 4,225 is 65. And that would be in miles. Make sure to label on your word problems. Okay, do your assignment. And we'll talk about this later and answer questions at a later date.